So we will discuss some more problems on equilibrium of connected bodies. Here this is a examination problem of VTU January 2019. Determine the reactions developed at the contact points. The rollers are identical, that means similar, with each weighing 1000 Newton. So there are two rollers here given in the problem. They are lying on an inclined plane and resting against a vertical wall. The angle of inclination of the plane is 20 degrees with the horizontal, and as he says, the rollers are identical. That means weight of this roller is also 1000 Newton. Weight of this roller is also 1000 Newton. The center of gravity of these two rollers are given as O1 and O2. So the question is, we have to find out the magnitude of the reactions that are going to develop at the contact points. If you observe the diagram, there are four contact points here. So I have noted that as A, B, C and D. So A and B are the contact points of the rollers with the inclined plane. C is the contact point of the first roller with the wall, and D is the contact point between the two rollers. Now O1 and O2, they are the center of gravities of the two rollers. So weights of these two, they will be acting vertically downwards. Of course, both the weights are equal to 1000 Newton as well. Now there are four unknowns here. There are four contact points here. A, B, C, D are the contact points. So at these contact points, reactions will develop to keep the system in equilibrium. So let me take the reactions as RA, RB, RC, RD. So these are the reactions. So we have to find out these reactions. Please note that there is no friction force here. Therefore, the surfaces are taken as smooth surfaces. All the contact surfaces are smooth surfaces. And these, as you know that in the case of smooth surface, only one reaction will develop, and that reaction will be normal to the contact surface. So all these reactions, they are normal. That means they are perpendicular to the contact surfaces. So that is the concept. So now let me analyze this problem. So there are four unknowns. So to solve for four unknowns, we need four equations naturally. And in the case of concurrent force system, we have two equations of equilibrium, sigma Fh0, sigma Fy0 for whatever free body diagram we are going to take. So since we need four equations of equilibrium, you have to consider the free body diagram of two objects here, because for each free body diagram of an object, we will be having two equations. So the set of equations will be one for this first sphere. I take this as first sphere or first roller. This I will take the second roller. So free body diagram of the first roller I am going to write. I will get two equations. Free body diagram of second sphere I am going to write. I will get another two equations. Totally you will be having four equations, and you have four unknowns: RA, RB, RC, RD. You can easily solve them. Now let me write the free body diagram of roller 1. First roller 1. So you know how to write the free body diagram. You have to remove the contact surface and replace them by the respective reactions. So the roller 1 is like this. The weight of this roller acts vertically downwards like this. 1000 Newton is the weight of the roller. O2 is the center of gravity of the first roller, yes, I have taken. Now RA, as I already told, this RA reaction at A will be normal to the contact surface. This is the inclined plane itself is the contact surface. RA is at right angles to the contact surface. Now if I write that RA, it will be like this. This angle, so this angle, whatever is there, this is 20 degree. When this becomes 20 degrees, this also becomes 20 degrees. When this is 20 degrees, this becomes 70 degrees. Please note that, that is very important, because this tangent and this radius, they are right angles. So this is 70 degrees. That means RA is making an angle of 70 degrees with the horizontal. Okay, you can take like that. Or 20, it is 20 degrees with the vertical, or 70 degrees with the horizontal. So this is one thing. Now there is one more contact point D here. So D is another contact point here. So here also you will be having a reaction like this. RD is the reaction. Of of course, this RD, this if you join this, because these two are identical spheres or rollers, identical rollers. When these two are identical rollers, means the radius will be same. Radius of both the rollers will be same. That is the meaning. So identical means radius is same or diameter is same. Radius is same. So when radius is same, if you join these two set of gravities of the two rollers, that line will be parallel to this inclined plane. Definitely, it will be parallel to that. Therefore, this angle made by this reaction RD also will be 20 degrees. So this is also 20 because this and this they are parallel. So this angle also will be 20 degrees. So you can take this angle as 20 degrees. Please note that this RD will be acting towards the roller. When you consider this roller, RD will be acting towards the roller like this. Arrow will be like this. So now, RD I have taken, weight of the roller I have taken. There are three forces acting on roller 1. So 2 reactions and 1 weight. Now we have to apply equilibrium equations for this to get the values of RA and RD. So here RA and RD they are unknowns. So let me apply the equilibrium equation. First equilibrium equation. Sigma Fx is equal to 0 towards right positive, forces acting towards right positive. So you have to resolve the forces here because this RD is inclined. If you resolve this RD force reaction, so this is the resolution because it is acting in the first quadrant. So this is RD cos 20 and this is RD sin 20. Similarly, you have to resolve this RA. So if you resolve this RA, horizontal will be like this, vertical will be like this. So please note that this RA is making an angle of 70 degrees with the horizontal. Therefore, this becomes RA cos 70. This becomes RA sin 70. And you need not resolve this 1000 Newton because it is vertical. Now I will apply the equilibrium equation. So if you apply that equation, so see here all forces acting in x direction. You have to consider towards right positive, left negative. RD cos 20 is positive because it is acting towards right. RA cos 70 is negative because it is acting towards left. And this doesn't have any horizontal component, only 2 forces is equal to 0. So this is the equation 1 we got by applying sigma Fx is equal to 0. So second equation, sigma Fy is equal to 0, upward forces positive, downward forces negative. So RD sin 20 is positive because it is acting upwards, RD sin 20, and this is also positive because it is also acting upwards, RA sin 70, whereas this 1000 Newton is negative because it is acting downwards is equal to 0. This is the second equation. Now you got 2 equations. You can solve these 2 equations by elimination method or using your calculator. You can do that. Now what I will do here is, first equation I will write like this: RD is equal to RA cos 70 divided by cos 20. So you get the relationship between RD and RA. So which is nothing but cos 70 by cos 20. So the value of cos 70 divided by cos 20 is 0.364. You can take 0.364 times RA. So RD is 0.364 times RA. This relation you can substitute in second equation and you can eliminate RD and you can solve. So substituting for RD as 0.364 RA in equation 2. So RD is nothing but 0.364 RA into cos sin 20 plus RA sin 70 is equal to 1000. I can bring that 1000 to RHS, minus becomes plus. Now you can take RA common here. So you will be getting RA into 0.364 times sin 20 plus sin 70 is equal to 1000. Therefore, RA is equal to 1000 divided by this. So I can take this as 1000 divided by 0.364 into sine 20 plus sine 70. So the answer is 939.68. 939.68. So the force value rate of the roller is in Newton, therefore RA also will be in Newton. 939.68. Please check the answer once again using your calculator and write the answer. So RA is 939.68. So as I already told, so if you get positive value of the reactions, unknown reactions, the assumed direction of the reaction is correct. That is the meaning. So RA, whatever we got positive, therefore its assumed direction is correct. Now substituting for RA in equation 1, that is equation 1 is RD is equal to 0.364 times RA. You can get the value of RD now. So 0.364 into 939.68, which comes out to be 342 Newton. 342 Newton. So these are the reactions at A and D. So that means by taking the free body diagram of the first roller, we got the reactions at A and D. So reaction at D. Now the another two reactions which are unknowns are RC and RD. So to get RC and RD, we have to consider the free body diagram of the second roller. So then we can apply the same procedure to find out the reactions at C and D. Now let us take the free body diagram of second roller. So write down the free body diagram of second roller. FBD of roller 2. So roller 2 is like this. O1 is the central gravity of roller 2. You have contact point C here. Of course, C will be here. So there will be a reaction acting at C. You have a reaction at C. So that reaction will be like this towards that object. Always reaction acts towards the object. RC I will take is passed through this O1 because they form a concurrent force system. Then you have weight of the sphere or roller. So that is 1000 newtons acting downwards. I have to write like this. Then you have B, contact point B here. So like this, something like this. This is RB. So this RB and RB they are parallel. So this RB will be like this. RB and RB they are parallel because these two are identical cylinders, radius are same. So the same procedure will continue here. This is making an angle of, so since 70 degrees with the plane. That's what we have proved earlier. Because this is given as 20 degree, this becomes 70 degree. So that is RB. Then you have one more reaction, RD. So please note that RD will be acting like this for the second roller. For the first roller, RD will be acting like this. For the second roller, RD will be acting like this. That means, you please note that at D, at the point D, you have RD in both the directions like this. This is point D. So for this is the sphere 2, this is sphere 1. So they are collinear, equal and opposite collinear reactions. So at D, for this sphere 1, this is the order. So towards. For sphere 2, this is the order. So please note that. So RD will be acting along this line. And you know that this since the identical rollers are there, that angle also will be 20 degrees. Now here we need to find RB and RC, because RD is already known. We have found out here 342 Newton. That's all. Now this roller is subjected to 4 forces now. So 3 reactions, RC, RB and RD, and 1 weight. So let us use the equilibrium equation to find those 2 unknown reactions here. So same procedure is adopted here. So what we will do here is, I will write sigma fx 0. Before that, let us resolve the forces along x and y directions towards right positive, upward positive. I have to resolve this RD force. If you resolve this RD force, horizontal will be towards that, vertical will be downward because it is in third quadrant. Angle is 20 degrees. So 342 cos 20 and this is 342 sin 20. And if you resolve this RB, horizontal component is towards left, vertical component is upwards, and RB is unknown. So therefore, and the angle is 70 degrees. Please note that angle of RB with respect to horizontal or x-axis is 70 degrees. RB cos 70, RB sin 70. And this doesn't have any resolution because it is a horizontal force. Now once you resolve, now let us write the equations of equilibrium. The first equation, sigma fx 0 towards right positive, force is acting towards right positive, RC is positive. This 1000 Newton doesn't have any horizontal component, therefore no force contribution from this. RB cos 70 is negative because it is acting towards left, and this 342 cos 20 is also towards left, minus 342 cos 20, so this should be equal to 0. So this is the equation we got. There are 2 unknowns we cannot solve. We call this as equation 3. Next, sigma fy is equal to 0, second equilibrium equation, upward positive, downward negative. This doesn't have any vertical component. So 1000 is negative because it is acting downwards. Then this also is negative, minus 342 sin 20, and this will be upwards, plus RB sin 70 is equal to 0. Now from this we can get the value of RB. So RB is equal to now, RB is equal to, so this 1000 plus 342 sin 20 divided by sin 70 degrees. So this is the value of RB. Let us simplify that. 1000 plus 342 into sin 20 is equal to divided by sin 70. So the answer is 1188.66. 1188.66 Newton. So this is the reaction at B. This is the reaction at B. Reaction at B. Now substitute this value of RB in this equation 3. You will get the reaction at C. Okay, so substituting for RB in equation 3. So substituting for RB in 3. So RC is equal to, if you bring to that side it becomes positive, RB cos 70, RB is 1188.66 into cos 70 plus 342 cos 20. So if you simplify this, you get the value of RC. So 1188.66 into cos 70 plus 342 into cos 20. So it is 727.92. 727.92 Newton. So this is the reaction at C. Reaction at C. So these are the answers. So we got the values of all the 4 reactions now. So we got Ra as 939.68 Newton, Rb as 342 Newton, Rc as 727.92 Newton, and Rd as 1188.66. 1188.66. So these are the answers we got. You can observe here the value of Rb is the highest. So practically you can see why Rb is highest value. So because the weight of this roller also will be acting on this roller, and this roller also is possessing some weight. So this roller will be subjected to more force, external force. So the more external force will be there on the second roller. Weight of this will be coming on this, a portion of that will be coming on this. In addition to that, weight of this roller also will be there. So that is why more reaction will be exerted here. So when more forces are acting on an object to keep the body in equilibrium, object in equilibrium, they should develop more amount of reactions. Whereas here, if you take this roller 1, this roller 1 is subject to only its weight. So weight of roller 2 will not be coming on roller 1. That is why Ra reaction is slightly less. So like this, physically you can check or verify and interpret your whatever values you have got. All the values you have got positive here. All the reaction values Ra, Rb, Rc, Rd. That means the assumed directions of the reactions are always correct. So normally what we do is, whatever may be the object at the contact point, suppose if this is the contact point, we take the reaction like this towards the object. If this is the contact point, towards the object like this. If this is the contact point, towards the object like this. So, and if suppose if another object is in contact with this object, then this is the common contact point for both this thing. So in that case, just like your point D here, in this case you will be having the reaction acting like this. It will be collinear like this. So for this sphere reaction will be like this. For this sphere reaction will be like this. So this is the common concept you should remember.